everyone. Let me just figure out the tech here, and then off we go. So, yeah, my name is Ansgar. I'm with the Ethereum Foundation. I just wanted to basically take the opportunity to give a bit more of like a broader overview talk, because I do think that oftentimes the Ethereum roadmap is a little bit opaque to a lot of people, where we kind of end up making decisions that it's not always quite clear like where we're coming from. And so I thought I'd just basically try to give a little bit of just general context for how we think about the future. So basically, I'm trying to structure this in two parts. So the first part is just why rollups. We've been talking about rollups for a long time now. I mean, the last talk was about rollups. A lot of talks here are about rollups. We've had this rollup-centric roadmap for 2 years now. Why is that? Why are they really a good idea, at least, in our opinion? And then basically transitioning that into the second part, where I want to basically extend that and to talk about like what does that mean then for the broader kind of future of blockchains, and specifically this term like modular blockchains that you might have heard thrown around quite a bit recently as well. So let's start. Why rollups? For that, first of all, I kind of want to, I'm not super happy with the terminology we always use, like layer 1, layer 2, that's very descriptive, but it doesn't quite explain why is this happening. So instead what I want to just do is I want to call these chains just execution chains. Like every normal blockchain, just like that is basically useful for users is an execution chain. So we could, you can take Bitcoin, the very first special purpose execution chain, the special purpose being, payments, store value, that kind of thing. Then Ethereum, the first general purpose execution chain. And what all these execution chains, and by now we have like thousands of them, have in common is that basically they all want to have like maximum functionality and maximum throughput, but they have to trade that off against security, right? And to really kind of drive that point home of like how that really is a quite fundamental trade-off, I really like this specific graph. So you have like the cost to run a full node, on one axis, and then the throughput that your system can provide on the other. And if you look at, say, the early blockchains, like you have Bitcoin, you have Ethereum, basically both kind of down there, where the cost is not like too high. Like ideally, everyone who wants to, that's of course an important qualifier. Everyone who wants to can run their own full node locally, but that also means that the throughput of these chains is fundamentally limited, right? And that is not just some like inefficiency of the algorithm. That's like really one of these crucial points. Like this whole approach of everyone validating everyone's transactions, it just fundamentally doesn't scale, right? We can make the virtual machine like only so much more efficient. At some point, basically, if you personally verify every time someone on the other side of the world wants to buy a coffee, this just doesn't scale, right? And so how people try to solve this in the past? So I just basically picked one arbitrary other example, like Solana, kind of placed this on the graph as well, and there is more throughput, right? So that's a good thing, definitely, but it comes at a cost, and the cost here is that basically they just run it on more powerful hardware. You can always linearly scale, but just basically throwing more compute at it. And the problem there is that now all of a sudden it's everyone who has the money can still run these like a full node on a data center basically, and that does give you the high throughput. But the problem is, if you're a normal user, right? Normal meaning that you can't afford that full node on a data center. You just don't want to spend like a big amount of money on that. Then basically, what happens if at any point anyone just basically tries to propose an invalid state transition? If there's like a 51% attack or something, well, basically you have two choices. Either you just go with the majority, you just trust that the majority of nodes, you ask what's the current state, that they tell you the truth. In that case, you're basically just vulnerable to them rewriting the rules. Or what you can always do is you can just halt and then go on Twitter and see like who's right, which nodes were telling the truth, which ones weren't. But you don't really you don't have a choice anymore, right? You can't just locally verify. So how do we basically what's our goal here? Where do we want to be in like 20 years, in 5 years, 10 years, whatever, how optimistic you are. And that's basically over here, right? That's the unicorn zone. That's where, and it's not supposed to be like a Uniswap. Like I gave this talk like once, and people are like, "Oh, the Uniswap." No, that's just a unicorn, Ethereum unicorn, whatever. And the idea is like you definitely want this property where you like far to the left, where everyone can trustlessly run their own node, can trustlessly verify, but you also want very high throughput, basically the best of both worlds, right? And how on earth can we get there, right? Like how can we make this jump? And basically for that, I just want to briefly come back to the Solana example and like look at this down here, right? the main downside of this high throughput, like high computation requirement node is really that if there ever is a disagreement, you have to manually resolve it. So, you know, we are computer scientists after all, so what if we just try to automate that? That's basically the whole idea behind rollups, right? What if we just take this and instead of manually resolving it, we have some sort of automated system. Now, that system does have to run on like a separate, you know, layer, but in that case, basically what you get is an optimistic rollup, right? It's still, that's why I put the same logo there, it's still an execution chain, right? It's basically yet another blockchain. It's just like a technicality that it's a layer 2 or whatever you call it. It's just a normal blockchain. But the way you run it is that you apply the changes optimistically, and then anyone can submit a fraud proof. And the fraud proof, again, that's just this disagreement here. It's just formalized into a machine-readable argument. So you can just basically go to the machine and you can tell it, this state transition was invalid. And then basically these fraud proofs are supposed to be automatically resolved on a settlement platform. So the only thing you need here to basically get this amazing thing we want is you need some sort of settlement platform. And you know, that's kind of where I'm going at in the future in a second here. But then also just to shout out that, of course, we have this alternative approach, and that's, I don't know, it's almost unreasonable that it even exists. It's one of these cryptographic magic things that just falls out of the sky. You just look at it very hard, and all of a sudden it turns out that, you know, you can just throw the magic on there, and like basically that gives you this alternative approach where instead of having to wait for someone to try and commit fraud and then basically catch them and revert the change, you can also design these systems where you can just basically automatically prove that a certain transition was valid without having to fully execute it, which basically this is just, you know, pure computational compression. It's really quite impressive that this is possible at all. But again, you need the settlement layer where you can execute this proof. And so then one other thing I just briefly wanted to mention, because it's really quite important and people sometimes miss this, is it's not only that you have to verify these proofs, there's one other aspect that's really crucially important, and that's why these days, like if you've ever heard the term danksharding or something, that's where this is coming from. The problem with these rollups is if you no longer run the full chain yourself, you only execute these proofs, there's one crucial new aspect, and that is that data has to be available. And what do I mean by that? Well, if you have an optimistic rollup and someone basically tries to commit fraud, the only reason that basically we can catch this and we can prevent this is that basically someone has to be able to look at what is happening, you know, on that maybe expensive data center machine or something, and then be able to see, wait, this was incorrect, let me construct a fraud proof. If they never get the data, if they never see like what is the claimed transition, they only see, you know, someone claimed, I took this state and I put it into this other state, but I don't tell you how, then there's no way to prove fraud, right? And so basically it's crucially important now that the data is still available, even though users don't want to download it, because again, that's kind of expensive, that you want to somehow check that it is available. And same with ZK rollups, not quite as bad, but you can also still like do really bad things if the data is not available. So what we need is, we also need this extra feature. It's not only about settlement, it's also about data availability. Yeah, and we can scale this as well with nice techniques. So now, basically with that hopefully kind of motivates a little bit, like, why do we want rollups? Why are rollups really kind of this amazing thing that gets us to this unicorn zone, at least hopefully in the future? Now, what does it mean for the future of blockchains? How will the architecture look like? So that's basically now where this modular vision comes in. So I really try to go all in on the pictures here, because usually they're lacking a little on my talk. So hopefully I didn't overshoot, but let's see. So this is basically just, you know, how I want to visualize a normal, you know, legacy kind of style blockchain. So even, you know, Ethereum today, kind of. So it's like, or at least, you know, 2-3 years ago. So it's basically just, you know, its own execution chain, and it has its own security. That's what that's supposed to mean. And it's just, you know, chugging along. And now we basically want to throw these new amazing capabilities at it and see what happens, basically. So we have like settlement, we have data availability. And one very natural thing, because, you know, rollups need both anyway, is to just bundle them. So that gets us what we call like a settlement chain. So a settlement chain is basically specialized in just providing these, like in a very efficient way, these specific types of functionality. And then the moment you got this, you basically now, instead of basically having to run these two independent chains with their own security, what you can just do is you can just take this execution chain and you can basically just settle it on top of that settlement chain. And as you can see, but all of a sudden, basically, it doesn't need its own security anymore, right? Because it just gets that for free from the base chain. And this is basically the most naive thing you can do. You can basically just take the settlement module and you can just basically apply, like, give every chain its own settlement module, right? So that's what we kind of call an enshrined rollup. So you have like, you could imagine, you know, Solana has its own settlement chain, Ethereum has its own settlement chain. Like everyone basically just runs their own settlement chain. And so you have like the full chain nodes that are quite expensive to run, and then you have the settlement chain nodes that give you the security that are quite cheap to run. And what that would get us to would be this world. That's kind of like what every time you kind of hear like about the MultiChain future, that kind of thing. That's basically what that could look like, and it's very much a plausible future. So basically, even though we at Ethereum believe that this is not the most likely outcome, or at least like is it kind of how most of the future will look like, this is very much a plausible outcome. So you basically have all these independent sovereign chains, and they all kind of talk to each other because users do want to cross, basically interact across multiple chains. But there are quite a few downsides. So one is to state that it's fracturing the security. So as you can see, all these little logs, they're all quite small. Basically, everyone has their own security budget, and that means that the amount of activity you can put on any single chain is limited because you can never basically go above its security level. And every time like one of these links breaks, then basically like that specific chain is no longer secure, basically. Also the bridges, that's one of these kind of fundamental problems with bridges, where like if you bridge two separate independent security zones, you basically always have to trust both separately. So basically you always get the weaker of the two securities, which is again like not ideal. And then also like you're just basically duplicating a lot of complexity. I mean, of course, ideally you'd have like kind of out of the box settlement functionality, but still it's a lot of duplicated functionality. So then what kind of alternative vision like do we have? And of course, I mean, the future will probably end up looking somewhat hybrid, but just to make the most extreme other point, that would be the shared settlement chain. So in this case, you have like a chain where one chain that provides settlement and data availability, and it has like a lot of security. And then you have like a bunch of different rollups on top. But again, these rollups, it's just a technicality to call them rollup layer 2. They're just their own blockchains that happen to all be anchored to the same settlement chain. And that's with both data and settlement. There are other systems, so like for example, Celestia, if you're aware of that, they basically only want to provide data availability, so then you would basically just settle the orange arrow on them, and then basically the blue one would stay independent. It has some trade-offs on the security side, but that's basically, this is the most clean other extreme, where you have one settlement chain, use it for both. And the nice thing that gives you is that you have shared security across all the rollups. People sometimes say that security is for free. That's not quite right, because it does, like, the more activity you have on top of a system, the more the security is strained. So if you use a settlement system and you're the only user, then basically you only worry about your own activity. But if there are 20 users, then of course, if the cumulative activity is like high enough that it is a temptation for someone to try and attack, that's still a problem, but at least you have pooled security, and that's really important, right? As long as the combined security is good enough to cover the combined activity, basically you're good. And then also the nice thing is that because you have like a shared source of truth, all the bridges can, in theory, be secure. I mean, modular implementation bugs, of course, which right now is the main source for bugs, but still. So then, kind of for the last few minutes here, let's talk about like what does it actually mean for Ethereum, like in these picture terms, how will Ethereum look like in the future? So start with the past. Like again, Ethereum started as just its own, execution chain, nothing more. There weren't yet rollups, not yet a thing. Proof of work security, that's kind of the Ethereum from 3-4 years ago. Then basically we go to Ethereum's present. We already now have these, basically, it turns out you can use the existing Ethereum chain basically as some sort of like hybrid system where it's mostly still an execution chain for end users, but also it has this settlement capabilities, because it's a general purpose chain, you can also use it to run fraud proofs, you can use it to run ZK proofs, kind of well enough, and then also it has some very limited data availability capabilities today, and very limited is what I'm saying. I'm not sure if how familiar you all are with the technical details, but basically we have this concept of call data on Ethereum. You can use that to just shove a bunch of data onto the chain. It's very expensive though, so this is really, that's why this logo is so small, because today's Ethereum really doesn't provide great data availability capabilities yet. And so because basically we have these things, we already have some first rollups on Ethereum, and we are very happy to house them with the limited capabilities we have today. And then we also have, and this is particularly relevant these days, we have this other empty chain that and I have the next slide where this is going to disappear, and give it 2 more days. But that's the beacon chain, and for now, beacon chain doesn't really have any purpose. It's basically just an empty chain. But as you can see, it has much better security than our proof of work chain, and that's kind of what it's mainly for. So then, what's our next step? The merge tomorrow. Well, I was thinking Wednesday night when I was making these slides. Now it looks like it's Thursday morning, so it's maybe 2 days from now. But anyway, the merge, it's going to happen. It's going to be great. And then basically what that means is that it upgrades our security. And then just if you can see like this little box, the lock got even bigger after the merge. So I want to talk about like where does all this extra security come from, basically, just as a quick aside, So side note on security, like where does it come from? First of all, we have the upgrade, proof of work to proof of stake. Again, people, I don't know if you open Twitter, mistake already made, but like you see a lot of conflicting views on this. Of course, we are very much convinced that this is the way to go in terms of security. It's just more efficient, just because as a very basic point, for proof of work mining, basically you have to offset the entire cost that the operation basically causes to the miner. You basically have to offset their cost for buying the equipment, you have to offset their energy, so you basically offset the entire capital investment. Whereas on proof of stake, you only have to offset the lost interest that they could earn with the Ethereum otherwise, right? So you still get the full benefit of the capital used, but you only have to offset the interest, which is like much more efficient. So that's like a 10x right there, or like a 20x or whatnot. And then it's also more effective because in proof of stake, fundamentally, whenever someone tries to attack the chain, you know exactly who that is, and you can punish them deliberately, like and selectively. Whereas on proof of work, you can't punish individual miners. So that's why we really like this proof of stake from security point of view. And then there's the other point that I just want to briefly mention. It's a little bit more out there. So if that's not your kind of cup of tea, then please, excuse me for making this point. But we have this other flywheel effect where, like, with the end of proof of work, we have no more mining rewards. That means that we have improved monetary properties for ETH, the asset, which we hope might mean that we have like a higher expected monetary premium that ETH might accrue in the long-term future, which would give it like a higher market cap, which would mean we could buy more security as like an overall absolute level. So that's, again, that's optional. This is our main argument, the top one. But if you happen to be into this, and I kind of like the whole ultrasound money situation, so then that might be like a nice second argument, and that's why I drew the box even bigger, but again, optional. So then bringing this back, we have the merge. Just very briefly in terms of future upgrades, and I'm not sure if how I'm in time. My watch doesn't work. Anyway, I hope I'm still kind of okay. So it's basically done. So just to briefly give you like a brief expectation. So like again, as we're saying, we don't have amazing data availability yet. So we have this upgrade called proto-dunk sharding that just will give us a little bit better data, and then hopefully soon we also have full dunk sharding, which that will basically get us to this world where we have like full on highly scaled data, and then basically with that I think I'll basically skip over this. I just wanted to briefly say like what exactly kind of is the future of ETH1, and like do find out. I'll put the slides on Twitter, so if you want to read this in more detail. But basically, there's still a lot of variability. Like we could actually even do this. We could pull it back out. The nice thing with modularity is just it's plug and play. Like we don't know exactly where we're going yet, but like there are a lot of interesting different alternative like variants of this future. The future of the EVM likewise is like very much open. Will like these future highly scalable blockchains be EVM based or not? We're going to see. We're doing our best to support this kind of future. We have a lot of research, past research on this that's still very helpful for EVM-based rollups, but also there will be non-EVM-based rollups. You could even, I think, something like Solana, again, they will add, at some point, they'll add some sort of settlement functionality, either like as a sovereign rollup, maybe they'll even settle on top of Ethereum, I don't know. But if they end up winning out, that's fine as well. Like again, we are not like we of course we're rooting for the EVM, but it's by no means guaranteed that the EVM will be the dominant kind of execution chain of the execution VM of the future. And with that, just like as a quick summary, basically, let's see. So, I also could, I guess I always look there. Anyway, so summary, traditional blockchains have to always trade off. This was the graph in the beginning, security and scalability. Rollups fundamentally solve this. It's fundamentally different from normal chains, and it's fundamentally different even from these highly scalable layer ones that you always hear about today that just don't care about the security side of things. And they solve this by outsourcing the security to the settlement chain. It's not, again, it's not free, but it's pooled, which is like amazing, and you can run these very lightweight settlement nodes and get full security guarantees. Ethereum's vision is within this to become the primary settlement chain, right? That's kind of, again, we are very much looking forward to this sprawling future where basically we'll probably see all these different experiments run, but we very much expect and predict that we'll end up with one dominant settlement chain, and we're basically trying to provide the service. We're still very much at the beginning of this transformation, right? Right now, rollups are still in the infancy. A lot of what this will actually mean for the ecosystem is yet to be determined, I think. And Ethereum might still also have execution chain ambitions of their own, right? So we're not necessarily going to turn only into settlement chain. Let's see what the future holds, right? But this is our primary focus for now. And with that, that's it. Come talk to me.
Thank you so much. We have time for one, but really, really good question. Think twice. Is it a good one? Totally? All right. Okay, let's do this one.
I'm biased, but first of all, thanks for the presentation. And I totally like the idea about the shared settlement chain. The only caveat being, while it cannot be said enough and enough that having a unified source of security, it definitely brings us advantages in standardization, but it also gives like a single vulnerable, basically an attack vector, because think of the hard bleed that happened with the SSL. So how does that interplay with this shared security, standardized security, but also a single attack vector? And with the TVL locked and plentiful of the chains, it will be there. Only when.
Yeah, no, I think that's a really good point. I think at the end of the day, basically, it's always easier to try and mitigate these kind of concerns within the kind of the single settlement chain framework. So, for example, what's been really one of the leading design considerations of Ethereum in the past has been this multi-client approach, right? And so that's specifically like why we are doing this and why like almost no other chain is doing this, because we really want to basically have like full redundancy. Specifically because like it could always be that there's a client that has some sort of bug in it, and we really don't want the entire chain to fail, to have like the single point of failure. So you can always kind of try and add back redundancy within the system architecture. And I think that basically because you really want these properties that you get from a shared source of security, I think it's always the more practical approach to go. But again, I definitely think it's very plausible that we end up in a world where some communities decide that they want to stay sovereign. So, for example, I listened to a podcast with Zuko from Zcash the other day, and he was saying that he's somewhat skeptical of this for now, and they might choose to, even at greater cost and slightly weaker security guarantees, to stay their own sovereign system because they really, really value that independence, and that's perfectly fine.
Thank you.
Thank you, Ansgar. Thank you. Round of applause.